Today we will discuss on the topic of fake news detection. Beware of fake knowledge, it is more dangerous than ignorance. Nowadays, spreading news across the world has become very easy as compared to a few years ago when news was only spread through newspapers and word of mouth. You can now spread news through any of the social media platforms like Twitter, Facebook, Instagram, etc. And so, news can now spread very fast across the world. However, there is a problem with this that has recently come to light. Due to the ease with which news can be spread, there has been a rise in fake news. So, what is fake news? Fake news is fake knowledge about some topic being shared to people over the world. Fake news is a big problem since, due to having read the wrong information, many people can take wrong decisions. When we are using WhatsApp and read a news article which has been forwarded, if the topic is a common interest of yours and a friend's, you will immediately forward the article to your friend. For example, if you have an interest in cricket and you receive the news that MS Dhoni has retired, you would immediately forward the news to your friend, who would forward it to someone he knows, and so on. And this way, fake news is spread using WhatsApp and other social media. The above example of fake news cannot cause much harm. However, there are articles of fake news on important subjects which are spread to misinform people about important matters and make them take wrong decisions. That is why the government and social media companies are constantly trying to solve this problem. And since COVID 19 is a topic which has affected the lives of everyone, fake news about COVID 19 has been repeatedly spread, from fake statistics to fake origin stories to fake remedies. Remedy advertising products. Products are advertised which are not able to heal COVID 19, but they are termed as COVID 19 solving products. Facebook recently flagged a lot of such posts. So, how did Facebook identify all that fake news? 50 million. So, how did Facebook do that? And what can we do to protect ourselves from fake news? On newspapers, when an article is published, it has the name of the editor and the author given. And in case of fake news, the author and editor can be reached, so the source of the news is given. But in case of social media, most of the articles or forwards have no author or editor name given. So we need to find the source of the news by finding which website published the news. Was it Times of India or some other well known company? Unless the news has been forwarded with a link of a known website, that news cannot be trusted. Another way to protect ourselves from fake news is to check for any other articles on the same topic by some well known news company, which will verify the news. So, how did Facebook manage to flag down 50 million fake news articles? Currently, fake news is identified and removed by three main players or agencies: the government, employees from the social media company who are hired for removing fake news, and consumers reporting fake news. The government only flags fake news which has attracted way too much attention. And the consumers do flag fake news, but not all the time. So mainly most of the fake news is flagged by the employees of the company who are given the task of removing the fake news. Now, the employees are supposed to go through all the articles being forwarded and search through the whole article before either flagging it as fake news or finding it to be real and letting it be. In either case, there are some problems with this approach. The first challenge that social media companies face in this approach is that it requires too much manpower. Hiring and training so many people to go through fake news articles is difficult. It requires a lot of expense and time. The second challenge is that this way of manually removing fake news isn't fast enough. Fake news has to be immediately dealt with, and before too many people have been misguided because of it. And when you give a group of people the job of going through so many articles, the process will be slow. Because just imagine, there are 50 million fake articles on one topic in 1 month. Then what would be the total number of fake news articles? This also refers to our third problem, which is too much data to handle. When a group of employees are tasked with going through so many articles, they will of course try to do it as quickly as they can. And though this method of doing the work will save time, it will increase the chance for errors, because when you're trying to do something very quickly, you may miss some details. And finally, our fourth problem, humans make mistakes. And over the course of 50 million chances, humans would make many mistakes. So the human accuracy at identifying fake news would be around 60 to 70%, which leaves a huge gap of 30% fake news which will still be spread. So these are our challenges. Now how will we deal with them? We need to create a method that can deal with fake news without much training, without taking much time or costing much. And this method should deal with handling massive amounts of data, and should be accurate at least 90% of the time. The answer to this problem is machine learning. Machine learning is when you train a machine to do tasks which humans normally do. This is achieved by giving the machine data from the past and letting it learn from that data how to predict the future. So we will give the machine our fake news data and ask it to learn from the data before it will be able to predict whether an article is fake news or not by itself. This will solve all of our problems, since machines are faster than humans, make lesser errors, can handle loads of data, and don't require much expense when compared to humans. Also, they do not need to be managed all the time. To create a machine learning model, we will be using Python since it is easy to learn and is one of the most efficient languages. Now, a machine cannot understand words. Machines can only understand numbers. So we must convert our words into numbers for the machine to understand. And a word cannot be displayed or conveyed by one number, because just like a word is a collection of alphabets, we need to use a vector which is a collection of numbers. So we need to convert our words to vectors, and to do so, bag of words was used previously. But bag of words has some problems. Mainly, it cannot understand or find important keywords. So it will have to go through the entire data, and the entire data is very large. So instead, we will be using TF-IDF, which is a word to vector converter, which can understand and identify only the important keywords. This will save time, computation power, and space. The reason we need to understand the important keywords is to reduce the time it takes for our machine learning model or program to analyze or learn from data. Now, normally logistic regression is a technique, machine learning technique, which is used in such cases where we have to predict a binary variable. A binary variable is a variable where there are only two possible outcomes, positive and negative. In our data, there are only two possible outcomes, fake and real. Logistic regression plots all the data points on a chart and then finds the line which fits the data best or is as close as possible to all the data points. It then takes the equation of this line and runs a sigmoid function on it. A sigmoid function simply converts all predicted values to probabilities between 0 and 1. So our machine learning model will predict what is the probability of our news being fake. However, we will not be using logistic regression, we will be using passive aggressive classifier. The reason is, as there are so many records, plotting them all and finding a best fit line will take very long. Passive aggressive classifier is an online machine learning algorithm. What this means is that instead of taking all the data at once, it takes the data in parts. and it is faster than logistic regression. Then after it has trained itself on the data, it makes predictions, and based on whether the predictions are correct or incorrect, it changes its method of prediction. Here I have highlighted how this machine learning model will work. First, we will take our data, which will have both real and fake news articles in it. Then we will split our data into two sets, training set and testing set. The model learns from the training data and then tests itself on the testing data by predicting on news articles whose results we already have. And after it has made its predictions, it checks whether it was right or wrong. We will be keeping 80% of our data as training and 20% as testing. Then we will use TF-IDF vectorizer to convert our words to numbers. After this, we will give our data to the passive-aggressive classifier, which will run 50 iterations or study the data 50 times. After this, we will test our model and we will get an accuracy of 90 to 92%. TF-IDF vectorizer is the main concept at the core of fake news detection. The way TF-IDF vectorizer works is it takes an article and finds the important keywords. It does so by using two concepts, TF and IDF. TF is term frequency, which refers to the number of times a word appears in an article. So in the example A here, the word Jupiter appears once. So the term frequency is equal to the number of times the word appeared in the article divided by number of total words in the article. So 1 is the number of times the word appeared in the first sentence divided by total number of words in the sentence, which are 5. So the term frequency for Jupiter for sentence A is 1 upon 5. IDF is inverse document frequency, which is the number of articles or sentences the word has appeared in compared to the total number of articles. It is mathematically calculated by log of number of total documents divided by number of documents the word appeared in. So in our example of the word Jupiter, it appears in one sentence out of two total sentences. So it is log of 2 upon 1, which is 0.69. The more articles the word has appeared in, the lower the IDF will be. So then we multiply our TF value with the IDF value and we get a TF IDF value. So in our case, 1 upon 5, which is 0.2 multiplied by 0.69, which will give you 0.138. Now you will notice that all the unnecessary words which are not keywords like is and the are eliminated by TF-IDF method. Is also given a value of 0 by TF-IDF and the is also given a value of 0 by TF-IDF. So this way only the important keywords are left. So also what this does is, if you were given a fake news about Jupiter, for example, you were given a news, Jupiter is the smallest planet. Here the keywords will be Jupiter, smallest and planet. The TF-IDF will then verify these keywords against previous articles on Jupiter that have been published before. It will find the keyword largest planet with Jupiter many times, but it will never find the keyword smallest planet. So this way our TF-IDF vectorizer will identify fake news. Before we go into passive-aggressive classifier, we need to understand how a classifier works. A classifier uses all of our variables, in this case all of our words, and based on that tries to predict the results. It learns how to do so by observing past data and learning from it. So one of the most basic machine learning algorithms is linear regression, which simply fits a line to the data, checks the distance between every data point and the line, and tries to make that distance or error as low as possible so that the line fits the data perfectly or as perfectly as possible. Then, based on where our x variable lies on the line, it can predict our y variable. So it uses the standard equation of a line where y equals mx plus c. Here m is the slope and c is the y-intercept. A y-intercept is where your line first appears on the y-axis, or where your line is when x is equals to 0. So for example, if your line starts at x equals 0, y equals 3, and then moves ahead, then our intercept of y equals 3. So to find the intercept of y, simply take x equals 0 and find at what value of y does the line start. In this case, we have only one independent variable, which is simply the variable we use to predict our dependent variable. But what if we have multiple x variables? Then you will have multiple values you can use to predict your y. Previously, the most accurate variable was used, but because we are not using the other variables as well and only using one variable, the accuracy was limited. Now we can use multiple variables, due to which our prediction of y is more accurate. So our new formula becomes y equals m into x1 plus x2 plus x3 plus x4. x1, x2, x3 and x4 are all of our independent variables, or the variables which we are going to use to get our predicted variable. But the slope, which is the value which tells us how much effect x for how much change in x is there a change in y. So how much does x change y will be different for every variable, because every variable will affect y in a different way. So we will need to have a different slope or different change or weight for every variable. So the new equation becomes y equals weight 1 into x1 plus weight 2 into x2 plus weight 3 into x3 plus weight 4 into x4 plus bias. Bias here also refers to the y-intercept. Now suppose your model made an error of 12%. So simply when you added up all the distance or errors between the line and your data points, the average came out to be the total came out to be 12%. And your model wants to reach the lowest possible error. So what will it do? It will adjust the weights or the effect every variable has on y to give more or less importance to the variables. And the amount by which the weights will be adjusted which is here called incremental step, is actually known as the learning rate. The faster your model wants to learn, the bigger the learning rate. But then why would anyone keep a small learning rate? Everyone would want their model to learn at the fastest pace possible. This image here shows the cost and the weights. Cost is the error and weight is the value which gives our x variable importance. We will obviously want to decrease our error. And the point or weight at which we have the minimum error is called global minima. This is the point where we want to reach. And the weights at this point are the weights we want to use. The learning rate is simply the value by which the weight will be changed to reach the global minima. But if you keep your value too big, it might hop right over the global minima and your error will never reach the lowest point. In fact, after the error decreases for a while, it will hop right over the global minima, and then the error will start rising again because you have once again reached a extreme of the weight. Before you were having a very high weight, now you're having a very low weight, so the error is once again increasing. So that is why you shouldn't keep a very large learning rate. This method of decreasing the weights to reach your lowest error is called gradient descent. Passive-aggressive classifier is also a machine learning model which uses gradient descent to reach the lowest error. But the way passive-aggressive classifier is faster is that it takes data from the web by web scraping, which is simply when you train a Python program to go through the web searching for a topic and sending all information of it to you. So, passive aggressive classifier takes the data from the web, breaks it down in many parts, studies them one by one or sequentially, makes predictions on the testing data, checks if its predictions were wrong. If they were wrong, it gets aggressive or it gets active. It starts changing the weights, applying the learning rate. If the prediction is correct, it doesn't change anything, it remains passive. Weights is simply the value you multiply by a variable to achieve your target prediction. For example, total profit of a company affects the share price. So the exact amount or the exact ratio by which it affects the price is the weight. So if a company made a profit of 4 million and the share price increased by $4, then the weights are 1 divided by 1 million. So if you adjust your weights, you adjust how much a variable affects the output, and because of that, you change the way your classifier is making predictions. Now this was the conceptual part of the project. We will now be going to the programming part of the project. We will be using Python and a software called Jupyter Notebook. First, we will import necessary libraries. What are libraries? Libraries simply consist of large blocks of code which are given small functions or names through which you can call them. Earlier, when there were no libraries, you had to manually code everything yourself. For example, if you don't know the name of a person and want to talk about him to a friend, you will have to ask your friend the guy's name by giving a list of his features, how he looks, where you have seen him, what he wears, etc. And then your friend will recognize him and give you the name. When you start using the name, you no longer need to describe the whole person. You can just use that one word name and your friend will know who you are talking about. Similarly, when using libraries, you don't need to type in the whole code. You can just call the code from the library and use it. For example, if I wanted area of a circle, rather than manually coding pi r square, I can just say import area from numpy area of circle, and it will give me this area. Different libraries are used for different use cases. NumPy is for math. That's why when I wanted the area, I went to NumPy. NumPy handles all the math operations like area, mean, median, mode, etc. Pandas is for handling and changing your data. If you want to remove a column, add a row, you want to simply transform your data, you go to Pandas. sklearn is a very important library which has a lot of machine learning functions in it. So from sklearn we are importing train test split, which I have already explained. It splits the data into two sets. Then we are importing TF-IDF vectorizer and passive aggressive classifier. Now our data will be saved somewhere on our computer. So we first have to get the file path, and then we'll be able to read our data into the program. Our data is in a CSV format or comma separated values format, which simply means when every value of the data is separated by commas. Now we will get the shape and head of our data. Shape will give us how many rows and columns are present in the data, and head will give you the top 5 records of the data. So you can have a look at the articles in your data set. Now we are having a look at our results variable, also known as labels, also known as target. And we are saving the results separately since we want to be able to test our data by not giving the results and only the articles after it has done its training. Just like you as a human being first studied with all the answers before you went to give the exam. When you went to give the exam, you only had the questions. You did not have the answers, so you had to remember or predict the answers based on your previous knowledge. And then you get to know your score, which is how many marks you scored. A machine learning model learns in a way very similar to humans. It will also first study the questions or our x variable versus our answers or y variable, and then based on the knowledge it acquires, based on the knowledge it acquires, in the sense based on the patterns it identifies, it then is able to predict by itself, just based on the question or the x variable, what the y variable should be, and then we check the accuracy. Get dummies will simply convert our labels or our real and fake categories into zeros and ones. As I have mentioned earlier, this has to be done. Since the machine cannot understand words, it can only understand numbers. We are doing train test split. Our test size is 20% and our train size is 80%. Random state is used so that you can get the same set of random values again. Simply the number 7 in this case is a seed used to generate a set of random records. So by this number 7 is like a passcode. So you give it the 7, and based on that 7 it will give you the records, which are simply the random values stored in 7. So this helps, as everyone can be working on the same list of random records by using the same data with random state. Next, we are creating our TF-IDF vectorizer. Stop words equals English. Stop words are words which don't add anything new to the article or sentence. They are a list of words used by humans to make the sentences sound right. But the machine only needs keywords. It doesn't need words like is, the, for, as they are not keywords and they will not help. They are just occupying space. So it removes them. Now we are fitting our TF-IDF on our data and transforming the data into so that it only leaves the important keywords and removes everything else. Now we are calling our passive aggressive classifier. Iterations equals 50 means that our passive aggressive classifier will get to study the data a maximum of 50 times to reach global minima, and then it can make predictions. Now we are getting our predictions and calculating our accuracy score, which will tell us how accurate our model is. Accuracy score is calculated by comparing our predicted values with the test values. So y predicted minus y test equals error or loss. So if our loss is 0, our accuracy is 100. If our loss is 1, our accuracy is 99. So loss and accuracy are of course related. Finally, we will create a confusion matrix. A confusion matrix is a way to summarize the classification result of an ML model. It contains 4 sections: true positives, true negatives, false positives, and false negatives. True positives means that your model predicted positive and it was a positive. True negative means your model predicted negative and it was negative. So these true positives and true negatives are accurate predictions. So you can see they are highlighted in green. False positive means when your model predicted positive but it was negative. And false negative means when your model predicted negative but it was actually positive. So these two are incorrect classifications. That's why they're highlighted in red. Remember these terms because they will be used in later projects. We are using Seaborn, which is an awesome visualization library. Usually people use Matplotlib, but Seaborn plots look much better, and nowadays Seaborn is starting to gain a lot of followers. Anode equals true means we will have our label names displayed. For example, in this sample chart here, the name positive, positive, negative, true positive, false positives, all this will be displayed. Also, we will have the number of records. Like here it just says true positives, but it does not say how many records were true positives. If you want that number also displayed, we will have to do anode equals true, so it will annotate the numbers. CMAP equals blues will display our entire confusion matrix in shades of the color blue. So the list of challenges we were facing have all been solved by using machine learning. Too much manpower was solved by machine learning, which can observe the way a task is done and replicate it. The process is not fast enough was solved by passive aggressive classifier, which splits the data and learns faster. too much data to handle was solved by TF-IDF vectorizer. TF-IDF vectorizer, which only keeps the important keywords and removes all the unnecessary words. And human error was 30% was solved, as our model gives 92% accuracy and only 8% errors. There are still improvements that can be made in our model. Since we are talking about 50 million fake news on only Facebook on one article in 1 month, there is a huge amount of fake news. So even 8% error, if you just take the 50 million example, will still leave 4 million fake news unattended, which is still a big number. In order to deal with this, there is a new algorithm which was launched in 2020 named BERT, which can correctly classify 98% records. We will cover this in a future video with web scraping and word2vec.